We have a look at question 3, which says that you have the equation of an instantaneous voltage across a discharging capacitor as a function of time t, v of t equals v0 times exponential to the minus t over tau. v0 is the initial voltage and tau is the time constant of the circuit. First, we want to draw a graph against time for v equals 14 volts and tau equals 4 from t0 to 5 seconds. Question number B, calculate the gradient at t equals 3, t equals 5. Question C, differentiate this function, calculate the first derivative, evaluate at t equals 3 and t equals 5. D, compare the answers for part B and part C, and E, calculate the second derivative of the function. So let's start with A. The formula V of t is V0 times e to the minus t over tau. V0 is 14 volts, tau is equal to 4. So the function becomes v of t equals 14 times e to the minus t over 4. And I want to plot it, so it's going to be an exponentially decreasing function. For t equals 0, the voltage starts from 14 volts. That's 1 point, and for t equals 5, the value v of 5 is going to be 14 e to the power of minus 5 over 4. So 5 is here, 0 is here. So the y coordinate is going to be 14 e to the minus 5 over 4. Exponentially decreasing, so it will look like this. Again, you can use Desmos to plot the function. That's for A. Now for B, we can calculate the gradient for t equals 3 by taking a limit. I will show you how it is done. Limit as t goes to 3 of v of t minus v evaluated at 3 over t minus 3. So that's going to be the limit as t goes to 3, as t approaches 3, of v of t is 14 e to the minus t over 4 minus v of 3, 14 e to the minus 3 over 4 over t minus 3. Now if you put t equals 3 here, the numerator becomes 0 and the denominator becomes 0. So this is going to be equal to the limit as t goes to 3 of the derivative of the numerator over the derivative of the denominator. The derivative of numerator is going to be, the derivative of the second term is going to be 0. The derivative of the first term is going to be 14 e to the minus t over 4 times negative t over 4, derivative of that, over the derivative of minus 3 is 0. The derivative of t is going to be 1, so that's going to be over 1. So that's going to be the limit as t goes to 3. 14, and then you have the derivative of this going to be minus a quarter, so that's going to be minus 14 over 4 e to the minus t over 4, and then plug t equals 3 back here. It's going to be minus 14 over 4 times e to the minus 3 over 4. That is the gradient at t equals 3. Then the gradient at t equals 5 is the same process. You take the limit, t goes to 5, v of t minus v of 5 over t minus 5. So that's going to be the limit as t goes to 5. 14e to the minus t over 4 minus 14e to the minus 5 over 4 over t minus 5. Again, if you plug t5 into the numerator and denominator, you get 0 over 0. And you can find, the limit is going to be equal to the limit as t goes to 5. The numerator is 14e to the minus t over 4 minus 14e to the power of minus 5 over 4, derivative of that, over t minus 5, derivative of this. So that's going to be the limit as t goes to 5. The derivative of numerator is going to be the following. This derivative of the second term is going to be 0. So it's going to be 14 times e to the minus t over 4. The derivative of the denominator, the derivative of minus 5 is 0. The derivative of t is just 1. That's going to be the limit as t goes to 5. Minus 14 over 4 times e to the minus t over 4. And then you plug in t equals 5 and you get minus 14 over 4 times e to the minus 5 over 4. That is the gradient at t equals 5 seconds. Now for C, we do the following. We find the derivative. So we have v of t equals 14e to the minus t over 4. The derivative of that is going to be 14 times the derivative of the exponential is the exponential e to the minus t over 4. And here, because we don't have plain t and we have a more complicated expression, is going to be minus t over 4, derivative of that. The derivative of t is going to be 1, so it's going to be minus a quarter times 14 minus 14 over 4 times e to the minus t over 4. And you can simplify that. Well, let's leave it like this. So minus 14 over 4 times e to the minus t over 4. Evaluate the derivative at t equals 3. This will give minus 14 over 4 times e to the minus 3 over 4. And evaluate the derivative at t equals 5. V prime of 5 is going to be minus 14 over 4 times e to the power of minus 5 over 4. D, comparison. The results are the same. The gradient at t equals 3 is equal to the derivative evaluated at t equals 3. So that is minus 14 over 4 e to the minus 3 quarters. And the gradient at t equals 5 equals with the first derivative of the function evaluated at t equals 5. And that's going to be minus 14 over 4 times e to the minus 5 over 4. So the results are exactly the same. Now for E, we want to find the second derivative. Is going to be what? We know the first derivative of t. The first derivative of t is minus 14 over 4 times e to the minus t over 4. Go and differentiate this. So it's going to be minus 14 over 4 times e to the minus t over 4, derivative of this, minus 14 over 4 times e to the minus t over 4 times minus t over 4, derivative of this. The derivative of minus t over 4 is going to be minus a quarter. So it's going to be minus 14 over 4 times a quarter is going to be 14 over 16 e to the minus t over 4. And you can simplify the fraction is going to be 7 over 8 times e to the minus t over 4. And that is the equation for the second derivative of the function.